Hey guys, it's Mr. C, and in this video we're going to solve some one-step equations with addition, subtraction, multiplication, and division. All right, so we're going to work through a bunch of examples here just to see how this works. And in this example, let me change colors here. We have a one-step equation. So a one-step equation means we do one step and then it is done. When you are solving an equation, you want to isolate the variable, get it on one side by itself. And so what happens is you have to take these equations and you have to unwrap them like a present. So when you have a present you're going to give to somebody, you have to wrap it up and use tape and everything like that. And then the person just immediately rips through it, takes the tape off, and then undoes everything you just did. That's called an inverse operation. That's an inverse, when somebody undoes something that you did to get that present back. So what we need to do is undo all the things with the variable until it's by itself, okay? So we're not going to work with the other side yet. We're going to just work with the variable. And as we do that, changes are going to happen over here. And those changes are going to result in the correct solution. The solution is the number or the thing that when you plug it in, it makes the equation true. So we'll check them sometimes and sometimes we won't. But you should always check them when you're doing them by yourself. So we have a one-step equation and it says 4 plus a equals -3. And so we need to get that a by itself, but a 4 is added to it, a positive 4. So we need to get rid of that 4. And the way to get rid of a number or a thing is to do the opposite to it. So the opposite of a addition with this positive 4 would be to subtract 4 on both sides. Now what a lot of teachers are going to show you is this equation is like a balance, one side and the other. And you have to always keep that equation balanced. And so what you do to one side, you have to do to the other. And so some teachers are going to draw what's called the river here. And if you do something to one side of the river, you have to do it to the other side, not to the same side. So you don't want to subtract 4 from A right there. You want to do it on the other side. Now, what we did was we subtracted 4 on both sides. These are additive inverses. Opposites is what you used to call them. Now they're additive inverses. They cancel out. And whatever's left, you just bring down. So we're going to bring down our A, still equals -3, take away another 4 would be a -7. You have to be fluent with negative numbers and addition and subtraction. You have to, all right? So you might need to practice that. So what I have now is I have A is equal to -7. All right, so I'm going to check this one. So here's my check. And if I have 4 plus, and I'm claiming that A is -7, right? That is supposed to be equal to -3. Well, let's find out if it is. When you have a plus and a minus together like that, side by side, the minus always wins. And minus and negative are really the same thing. So 4 take away 7, as you've learned before, is going to be -3, right? And so -3. So -3 is right there. I was looking down here. So -3 is the correct answer because that's what we originally had on the right-hand side. And so that has to be true because -7 is our solution, which again, when you plug in -7 for the variable and you do your arithmetic, you get this value back. And so we call that the solution. So -7 is it. All right, so some of these I'm going to check and some of these I'm not, just for time. Here we have a 17 plus V is equal to 3. I really need to get rid of that 17, and it's a positive 17. So what I'm going to do is I'm going to draw my river, and I'm going to subtract 17 on both sides. Additive inverses cancel out. I'm going to bring my V down, equals, and now I have 3 take away 17. And so that should result in a -14. And then that's it. One-step equations, literally that's what it means. It's one step and then done. Okay, here we have this one. M minus 6 is equal to 19. Here I'm subtracting a 6 from the M, so I really need to get rid of that -6. So here's my river. So to get rid of a -6, I need to add 6 because that's the inverse operation. Additive inverses should always cancel out. I'm gonna bring down my M, equals 19 plus 6 is 25, and 25 is my solution. Okay, here we have another one, looks a lot like that one, so let's see how this works. Here's my river. K minus 3, So again, I need to get rid of the -3, so I add 3, add 3, additive inverses, cancel out. You'll hear me say that a lot because I want to make sure you know your properties. 10 plus 3 is 13, and k is equal to 13. That's my solution. Now the variables aren't always on the left-hand side. They don't have to be. Here are the variables over here on the right-hand side. Still have a river, doesn't matter. But if I look at my variable, the -5 is holding me up over here, right? I need to get rid of that -5. So I'm going to add 5 to both sides. So those cancel, additive inverses, a -12 plus 5. So you know what -12 plus 5 is? That should be a -7 equals x. And you can either write it like this, or if you want to, since it's an equation, you could write it as x equals -7. Either way is fine for me. All right, so now we've got some fractions, just to review some fraction concepts. Again, rivers right there, -6, -6. So g is equal to, and now I run into an issue. What is 2/7 minus 6? Sometimes you have to do a little scratch work on the side. We call it scratch work. So we have 2/7 minus 6/1. Okay, so what we need to do is get a common denominator. So what we're going to do is we're going to fix those up so we get our common denominator. So 1 and 7, the common denominator would be 7. So 7 there, 7 there. Now, since that 7's already here, the 2 just drops down also. I don't need to fix that fraction up. I need to fix this one up. So 1 times 7 is 7. 7 times 6 is 42, right? And 42 divided by 7 should give us 6. And so if you check that, and so you probably should if you don't know your multiplication tables very well, but 7 times 6 is 42. 2 take away 42 now is going to be -40 over 7. So -40 over 7 should be it for that one. All right. Here's our next one. We've got a couple fractions in this one. It's okay, it's not that bad. So we're going to add 1/3 to both sides. Those cancel. And now b is equal to, all right, and let's do our scratch work over here. 2/9 plus 1/3. All right, our common denominator, we really have a common denominator of 9, right? Because 3 times 3 is 9. And so what I'm going to do, just to make life easy on us, I'm going to make 9s here and here, and I'm going to rename these two fractions. Well, I don't really need to rename this one because I've already got the 9 there in the denominator. 3 times 3 is 9. 3 times 1 is 3, right? So 1/3 is equivalent to 3/9. 2 plus 3 is 5. And once you calculate that, you can just put that over here. And why am I doing it this way is because I know a lot of people can use a calculator and we all like calculators, but if you constantly use a calculator, even into college, you're going to forget this basic math that they teach you in 4th grade and you're going to lose it and you'll have to get it back because you're going to have a teacher that's not going to let you have a calculator at some point. And when that happens, that's traumatic if you cannot do this kind of simple calculation. So you always want to do it without a calculator just to keep your skills sharp. All right, so here we have another one. 2 fractions this time. I've got this 5/4 in front of the x, so I really want to get rid of it. So I'm going to subtract 5/4 on both sides. And what happens sometimes is students will look at fractions. They know what to do. If that was a 1 there, they'd know to subtract 1 on both sides. But they see a fraction and they just shut down. Well, you don't have to shut down. It's the same process for every single one. Cancel those out. They're additive inverses. Bring down your x is equal to, and now we just have to do the inevitable, 7/3, and we have to subtract 5/4. All right, so now we, again, need to get a common denominator, and this time we have to fix both of them up, don't we? So 4 and 3, the common denominator, the least common denominator is 12. Now you can always get a common denominator by multiplying them together, but you get at least one if you just kind of think about it a little bit. 4 and 3, though, have nothing in common, so we would have to multiply those together to get 12. No factors in common. All right, so 3 times 4 is 12. 4 times 7 is 28. So 28 over 12 is equivalent to 7/3. Okay, 4 times 3 is 12. 5 times 3 would be 15. So now we have to calculate 28 take away 15, which is really going to be 13. So 28 take away 15 is going to be 13 over 12 still. And so 13 over 12 would be our answer for this one. All right, so we've tackled the addition and subtraction. Now let's tackle the multiplication and division ones, fraction ones. 3x is equal to negative 51. All right, so we're going to draw our river. What's the opposite of 3 times x? Well, the opposite, to get rid of that 3, since you have multiplication going on here, you have to divide. So we have to divide both sides by 3. And so when we divide both sides by 3, those two guys cancel. And now we have x is equal to, and now you have to figure out what negative 51 over 3 is. So what if you don't have a calculator? If you don't have a calculator, you're going to probably have to do this. 3 and then 51. Remember long division? So 3 goes into 5 one time. 1 times 3 is 3. 2, bring down your 1. 3 goes into 21 7 times. And so it's 17. And actually it's negative 17 because of that negative right there. All right, or if your teacher lets you use a calculator, then you can use a calculator. So negative 17 is the solution for that one. Same process, it's just a different operation to get rid of that 3 because it was multiplied. Okay, here we have another one. We have negative 7 times a. So if I say negative 7 times a, the opposite of that is going to be division. So I have to divide both sides by negative 7, the whole thing, even the negative part. So those two cancel. They make 1. They are multiplicative inverses. The a comes down. And now I have 42 divided by 7, which is going to be 6. And you have a negative sign. So negative 6 is going to be your final answer for that one. So here we have one. K over 4 is equal to 6. So what do you do when you have a 4 down here? Well, when you have a 4 down here in the denominator, to get rid of that division, you have to multiply. Multiplication is the opposite. So we need to multiply both sides by that same number right there. So 4 and 4. These are multiplicative inverses now. They cancel. The k comes down, equals 6 times 4 is 24, and we're done. Okay, here's our next one. We're going to do the same exact thing. We're going to take that 5 right there. Here's our river. And we're going to multiply both sides by that same exact number to get rid of it, just like that. 5, and that's really a 1/5 is really what that is. And so these are going to be multiplicative inverses. They cancel. The d comes down, equals 15 times 5 is 75, negative 75. All right, now let's deal with some fractions here. Negative 1/3. Let's talk about that one. What's the multiplicative inverse of negative 1/3? So we used to call them reciprocals. So the reciprocal of negative 1/3 x, and I'm going to actually write that equation one more time down here so I have room. Okay, the reciprocal of negative 1/3 is really a negative 3. So I'm going to multiply both sides by negative 3 over 1. And I'll put that in parentheses too. Okay, when I multiply by the reciprocal, that is a multiplicative inverse. These two are going to cancel because they're going to make 1. There's really no confusion about it. You just take the fraction, flip it, keep the same sign, and when you multiply them together, you're guaranteed that they're going to equal 1 because they're multiplicative inverses. So these guys are going to make 1. And the reason why I cancel them out is because it's going to make a 1x, and I don't really care about that 1x. I just want the x. If I just write x, it's assumed that there's a 1 in front, right? I don't have to write it. Equals. All right, so how do we multiply these two guys? Negative 7 times 3 is 21. And 1 times 1, there's really a 1 down there. 1 times 1 is 1. That's your denominator, but you don't have to write it. So if I take negative 7 over 1 times negative 3 over 1, just to review, we multiply across, don't we? right? We don't cross multiply, we multiply across. So negative 7 times negative 3 is 21. 1 times 1 is 1. But nobody's going to write it like this. They're always going to just take the 21, because when you divide by 1, nothing happens. You just get rid of it. All right, turn my light back on. Yep. That's the fun part of doing this in a classroom where the lights turn out. Okay, so we got 21 for that one. All right, let's try this one. Okay, this time we got the variable on the right-hand side. And so now, how do we get rid of this? So there is a really easy way to do this. If you have a variable here and a single number there and a single number here, you can take these two and you can change them out. Just these two. You can change them out if you want to. Now here's what's going to happen. I'm going to take 16 equals negative 48 over b. All right. Here's what's going to happen. I have to get the b by itself. And so if I multiply both sides by b, okay, now here's what happens. That b and that b cancel because they're multiplicative inverses. And over here, I get 16b is equal to negative 48. The negative 48 just kind of drops down. Now I have to divide by 16, cancel out, and b is equal to, I think 16 goes into 48 3 times, negative 3. Okay, so I can do it this way, no problem. I'm going to get b is equal to negative 3. But let's try it my other way. I take these two items and I switch them out. I swap them, and I get negative 48 over 16. So watch what happens. I just got the same thing I had right here, right? Right there. I got the same thing. B is equal to negative 48 over 16. But I did it in one step and I did it in my head. So that is one little trick that you can do, and it will always work because of this right here. So 48 divided by 16 is still negative 3, and I still get the same answer. So my solution is still negative 3. So here's one, our last one has some fractions with it. So I'm going to actually write that again. Negative 4/3 x equals 15 over 9. So I'm writing it again because I'm going to need some space over here. So I really need to get rid of that negative 4/3 in front of the x. So what I need to do is I'm definitely not going to add, because that's a multiplication going on. But students all the time will look at that negative and go, oh, I need to add. No, that's not what's going on. These two guys are being multiplied, and the opposite operation is going to be division. The inverse operation is division. So what I need to do is I need to either divide both sides by negative 4/3, or even better, I'm going to multiply both sides by the reciprocal, which is the same exact thing. So I'm going to multiply both sides by negative 3 over 4, the reciprocal. So why am I doing that? I'm doing that because if I multiply these two together, I'm going to get 1. That's a guaranteed thing. That's a property. So now I don't have to divide by fractions. Cancel, cancel. 1x is equal to. And now I just have to figure out what all this mess is. So 15 times 3 is going to be, what, 45? And 9 times 4 is 36. And it's negative. This fraction has not been simplified. That's not in reduced form. So let's see if we can do that. Negative 45 over 36. Both of these numbers are divisible by 3. They both have a factor of 3 in them. So if I divide by 3 and divide by 3, I'm going to get negative 15 over, and 36 divided by 3 is what? 12? Like that. Okay, so 15 and 12, well, those are both divisible by 3 again. And sometimes you have to do this a couple times until you get it. Negative 15 divided by 3 is negative 5. 12 divided by 3 is 4. So I'm looking at negative 5/4. And so I'm going to claim that negative 5/4 is my final answer instead of this one that has not been simplified. Now, I could have done that a lot quicker if I'd been taught this. You go up to these two guys right here and you start canceling some stuff out. 15 and 9 both have a 3 in common. So I can cancel that out and put 5. And cancel that out and put 3. These two both have a 3 in common. I can cancel them out and put 1 and 1. And so now, when I multiply across, 5 times 1 is 5, 1 times 4 is 4, and there's my negative right there. So if a teacher has taught you that before in the past, that's a good thing. And if they haven't, well, then you're seeing it for the first time, and you can do that if you want to. So there's your video on one-step equations. Remember to like my video and subscribe to my channel, and we'll see you guys later. Bye.